Welcome to Investigating the Universe. Today, we're diving into a topic that often sparks both fear and fascination: asteroids. Specifically, we're tackling the question, will an asteroid destroy Earth in 2038? The short answer is no. The year 2038 will pass without a cataclysmic asteroid impact. However, this doesn't mean we're off the hook entirely. The threat of asteroid impacts is a real concern, and understanding this threat is the first step in protecting our planet. The 2038 asteroid impact myth likely stems from discussions about asteroid 99942 Apophis. This asteroid has been a topic of much debate and speculation over the years, leading to various misconceptions and myths about its potential impact on Earth. This asteroid, discovered in 2004, caused quite a stir in the scientific community and media. The initial discovery led to widespread concern and numerous headlines, as scientists scrambled to understand its trajectory and potential threat. Initial observations suggested a small but unsettling chance of Apophis colliding with Earth in 2029. This early data indicated a probability that, while low, was significant enough to warrant serious attention and further study. Thankfully, further observations and refined calculations have completely ruled out an impact in 2029. These updated calculations were a result of more precise measurements and a better understanding of the asteroid's path, providing much-needed relief to the public and scientific community alike. While Apophis will make an incredibly close approach to Earth, closer than some satellites, it will not hit us. This close approach will be a remarkable event, offering a unique opportunity for scientists to study the asteroid up close without the danger of an impact. The 2038 date might be a misunderstanding, as Apophis will make another close approach to Earth in 2036. This upcoming approach has also been carefully studied, and the data shows that, once again, there is no significant risk of collision. However, the risk of impact then is also extremely low. Scientists have used advanced modeling techniques to predict the asteroid's path, and all evidence points to a safe passage. The ongoing monitoring and research ensure that any potential threats are identified well in advance, allowing for appropriate measures to be taken if necessary. The story of Apophis serves as a reminder of the importance of continued vigilance and research in the field of asteroid tracking. It highlights the collaborative efforts of scientists and space agencies around the world, working together to protect our planet from potential cosmic threats. As technology advances, so too does our ability to detect and mitigate potential asteroid impacts. Future missions and innovative deflection techniques are being developed to ensure that we are prepared for any eventuality. The myth of the 2038 impact is just that, a myth, but it underscores the need for ongoing scientific inquiry and preparedness. Rest assured, the Earth is safe from Apophis, and the scientific community remains vigilant in monitoring the skies. The lessons learned from Apophis will continue to guide us in safeguarding our planet for generations to come. Before we delve deeper into planetary defense, it's important to distinguish between the different types of celestial objects often lumped together. Understanding these differences helps us better appreciate the unique characteristics and behaviors of each type.
Asteroids are rocky remnants from the early solar system, mostly found in the asteroid belt between Mars and Jupiter. These celestial bodies are composed primarily of rock and metal, and they can provide valuable insights into the conditions and materials present during the formation of our solar system. They vary in size from meters to hundreds of kilometers across. Some of the largest asteroids, like Ceres and Vesta, are so massive that they are considered dwarf planets. Despite their size, even the smallest asteroids can pose significant threats if they were to collide with Earth.
Comets, on the other hand, are icy bodies that release gas and dust when they approach the sun, creating their characteristic tails. These tails are formed as the sun's heat causes the comet's icy nucleus to sublimate, releasing gas and dust particles that trail behind the comet. This process not only creates a stunning visual display, but also provides scientists with clues about the composition of the early solar system.
Meteoroids are smaller pieces of asteroids or comets. These fragments can range in size from tiny grains of sand to large boulders. They are often the result of collisions between larger celestial bodies, which break apart and scatter debris throughout space. When a meteoroid enters Earth's atmosphere and burns up, it creates a fiery streak we call a meteor, or a shooting star. This phenomenon occurs because the meteoroid is traveling at such high speeds that it generates intense friction with the atmosphere, causing it to heat up and emit light. If a meteoroid survives the fiery descent and lands on Earth, it's called a meteorite. Meteorites can provide valuable scientific information as they are often composed of materials that have remained unchanged since the early solar system. Studying meteorites allows scientists to learn more about the history and evolution of our solar system.
Earth bears the scars of past asteroid impacts, proving that these events are not merely science fiction.
The most famous example is the Chicxulub impact, which occurred roughly 66 million years ago and is believed to have wiped out the dinosaurs.
While impacts of this magnitude are extremely rare, smaller impacts have occurred throughout history.
In 1908, a meteoroid exploded over Tunguska, Siberia, flattening trees over an area of 2,000 square kilometers. More recently, in 2013, a meteor exploded over Chelyabinsk, Russia, causing damage and injuries.
The potential threat of asteroid impacts, however small, is something we take seriously. This is where planetary defense comes in.
Planetary defense encompasses all the efforts to detect, track, and potentially deflect asteroids that pose a threat to Earth.
NASA plays a leading role in planetary defense, operating programs like the Center for Near-Earth Object Studies, or CNEOS, which tracks and analyzes the orbits of near-Earth objects.
International collaboration is also crucial. Agencies like the European Space Agency and others contribute to the global effort to monitor the skies for potential threats. If we detect an asteroid on a collision course with Earth, what can we do? This is a question that has intrigued scientists and space agencies for decades. The potential threat of an asteroid impact is a serious concern, and various strategies have been proposed to mitigate this risk. Scientists are exploring various deflection techniques, each with its own strengths and limitations. These methods are designed to either change the asteroid's trajectory or break it into smaller, less dangerous pieces. The choice of technique depends on factors such as the size, composition, and speed of the asteroid, as well as the amount of warning time available.
Kinetic impactor. This method involves crashing a spacecraft into the asteroid to alter its trajectory. By imparting a significant amount of kinetic energy, the spacecraft can change the asteroid's path enough to avoid a collision with Earth. This technique requires precise calculations and timing to ensure the impact occurs at the right angle and speed. NASA's Double Asteroid Redirection Test, or DART mission, which successfully impacted the asteroid moonlet Dimorphos in 2022, demonstrates this technique. The mission provided valuable data on the effectiveness of kinetic impactors and helped refine our understanding of how to use this method in future asteroid deflection efforts.
Slow push-pull techniques. These methods, like the gravity tractor, involve using a spacecraft's gravity or other forces to slowly nudge the asteroid off course over time. The gravity tractor concept involves positioning a spacecraft near the asteroid and using its gravitational pull to gradually alter the asteroid's trajectory. This method requires a long lead time and precise control, but offers a non-destructive way to deflect an asteroid.
Nuclear option. Detonating a nuclear explosive near an asteroid is a last resort, intended to vaporize part of the asteroid and alter its course. This method is considered when other techniques are not feasible due to the size or speed of the asteroid. However, the use of nuclear explosives in space is highly controversial and poses significant risks, including the potential for creating multiple hazardous fragments. However, this option is complex, controversial, and carries risks. The potential for unintended consequences, such as fragmenting the asteroid into multiple pieces that could still pose a threat, makes this a less desirable option. Scientists continue to research and develop these techniques, aiming to find the most effective and safest methods to protect our planet from potential asteroid impacts.
To ensure we're prepared for a potential asteroid threat, space agencies conduct planetary defense exercises. These exercises bring together scientists, engineers, policymakers, and disaster response teams to simulate different asteroid impact scenarios and test our response capabilities.
In 2021, NASA participated in a tabletop exercise led by CNEOS, simulating a fictional but realistic asteroid impact scenario. These exercises are crucial for identifying weaknesses in our current plans and improving coordination among different agencies.
While we've made significant strides in planetary defense, challenges remain. One challenge is detecting and tracking smaller asteroids. While we've cataloged most of the larger near-Earth objects, smaller asteroids, like the one that exploded over Chelyabinsk, are harder to spot.
Another challenge is developing and testing deflection techniques. While DART was a success, we need further research and development to refine existing methods and explore new ones. International cooperation and resource allocation are also crucial to ensure we have the resources to effectively address this global threat.
So, while an asteroid won't destroy Earth in 2038, the threat of asteroid impacts is a real concern. However, it's a manageable risk. Through scientific advancements, technological innovation, and international collaboration, we can continue to improve our planetary defenses and safeguard our planet for future generations. Thank you for joining us on Investigating the Universe. If you found this exploration of asteroid threats and planetary defense intriguing, don't forget to subscribe, like, and share this video with your fellow space enthusiasts. Until next time, keep looking up at the cosmos and never stop questioning the universe around us.